everyone, my name is Naranjan and today our subject is mathematics, and I'm about to discuss one of the types of variation, which is the direct variation. So let's begin this topic. I hope you're ready. So as you can see here, variation, it defines a concept that deals with variability. Variation is defined by any change in some quantity due to change in another, and also variation problems involve fairly simple relationships or formulas involving one variable being equal to one term. So now let's go with our topic. I will explain what is the meaning and I will give some examples of it. Direct variation, so it describes a simple relationship between two variables. So we literally saw this more on textbooks or in the internet. We say y varies directly as x, and when you translate this phrase in mathematical equation, we will have this equation y equals kx, which is this is the direct translation of y varies directly as x. Another thing about this formula, we all know that y index are the two variables, but we have k here, so what about the k? So the k is called the constant of variation or the constant of proportionality. So this is the example you see. Y varies directly as x and y varies proportionality as x. And these are the frequent phrases that you will encounter when it comes to direct variation. So this means that as x increases, y increases, and ax decreases, y decreases. So now let's give an example and I will explain how to solve direct variation. So I hope you're ready. I'm ready. Let's go. I just want to give some example to let you know what and how I will solve the direct variation. So I hope this paper is okay with you. Before I start this video, I already prepared some questions. So my first question is, if y varies directly as x, and x equals to 12 when y equals to 9, what is the equation that describes the direct variation? So this is what I prepare.
Now for the first example, we have here direct variation. That reads first, y varies directly as x and x is equals to 12, y is equals to 9. What is the equation that describes this direct variation? Now for the last part of this question, we are asked to find the equation that describes direct variation in number 1. Okay. Let's translate this first. We have y varies directly as x, meaning that this equivalent to y is equals to kx. But we're not finding this in our problem or answer. We are asked for the real equation for the first example that we have in variation. So how we will do that? First, you need to find the value of k. Find k. Give it the first part when which is x is equals to 12 when y is equals to 9, we can find out what is the value of k, given by x is equals to 12 and y is equals to 9. Simply substitute these values to the given y is equals to kx. So substitute, so we got 9 is equals to k times 12. Now if you simplify that, you will have 9 is equals to 12k. And then for us to find the value of k, we need to divide both sides of equation by 12. And simplifying this one, k is equals to 3 over 4. So this is the value of k, but we are not yet done because the question here is we're finding the equation. And for the equation, simply use this formula, which is y is equals to kx, and we know that your k is equals to 3 over 4, meaning we need to substitute this constant of variation for us to know the equation that describe this variation. So substituting the value of k, we will have y is equals to 3 over 4, or y is equals to 3x over 4. So this is our answer in number 1 question. And I'll give more examples. So let's have example number 2 for us you to get. So for the example number 2, we have suppose y varies directly as x and y is equals to 30 when x is equals to 6. The question here is what is the value of y when x is equals to 100? When x is equals to 100. So for the student like me, it will be very difficult because it has a lot of numbers here. Given y is equals to 30, or the x is equals to 6, using that equation you can transform it into y is equals to kx, and yeah, k is equals to w over x, because this is our formula to find a constant variation. And then we need to substitute 30 and 6, and we have here k is equals to 30 variable of y is over to 6 for the variable x. So just simplify this and we will got k is equals to 5. Simply means the constant of variation is 5, and because of that we can create an equation. And we will got y is equals to 5x. Y is equals to 5x. And right now we need to deal with our question here. What is the value of y when x is equals to 100? This is our main problem. So in this problem we're going to use this equation y is equals to 5x. So we're gonna put here find y using the equation y is equals to 5x. Given of our x is equals to 100, all you need to do is substitute the 100 and we will have y is equals 5 times 100. So simplifying this, you'll got y is equals to 500 and that's the value of y. So this is my last question and we will solve it. X is equals to 6. So it says here, if y varies directly as x and y is equal to 15 when x is equals to 10, then what is y when x is equals to 6? So it's just the same thing, you will divide it by 3. So let's try this first. Let's translate it with y is equals to kx. And we will look to this side to find the value of k. So find k. So you need to do here is y is equals to kx. Y is equal to kx. And your y is equals to 15 and x is equals to 10. You can change it, or if you want you will use k is equals to y over x to make it easier. We have k is equals to 15 over 10 is equals to 15 over 10. Simplify it to get this. K is equals to 3 over 2. That is our constant of variation. Therefore, we can this k into y is equals to 3 times 2. And now let's go to our main problem, which is what is y when x is equals to 6. So let's put here find y and the equation y is equals to 3 times 2 and your x is equals to number 6. So you'll just need to substitute the value of x. You can have y is equals to 3 over 2 times 6 and y is equals to 18 over 2. Then you will get y is equals to 9. This is the value of y of the given problem.
So thank you for listening and watching these videos. So I already give 3 examples, and I hope you understand my discussion, and it's just really simple. So I hope you understand. So thank you for listening and watching these videos. God, God bless.